So let's just practice a little bit more with these permutations. If we have, again, I will say the permutation, as we have right over here, 6, choose 2. According to our formula, that is going to be 6 factorial over 6 minus 2 is 4 factorial. We know we can rewrite the top as 6 times, so this I can rewrite as 6 times 5 times 4 factorial, which over 4 factorial means the 4 factorials will cancel out. So we're just going to be left with 6 times 5, or 30. Okay, I need to make a little room here. So let me just erase this. And 6, choose 6. So when I say 6, choose 6, well, if we had 6 letters and we were going to use all 6 of them, that should be 6 factorial choices. So let's see how the formula evolves here. I know we're going to have 6 factorial, and in our denominator, 6 minus 6 is 0 factorial. And what we know is 0 factorial is 1. So this is truly 6 factorial, which I remember is 720. For our next example, 5, choose 1, this is going to be 5 factorial over 4 factorial. And again, we know this numerator can be rewritten as 5 times 4 factorial. And the 4 factorials will cancel out, and that will leave us with 5. And think about it for a second why that would make sense. You have 5 puppies to choose from the Petco, if that's what you get your puppies, and you can choose 1. Well, you have 5 choices there. Whereas 7, choose 0, if you have a choice of 7 puppies and your parent says you are just getting 0 of them, well then you only have 1 choice, and that's, you don't get any. But let's see how that plays out in the formula. This is going to be 7 factorial divided by, well, 7 minus 0 is 7 factorial, which in fact does give us a 1. Okay, let's go on to the next problems. And, oh, how many different 3-letter code words are there using the letters in the word moo? Well, this is quite different than fun, isn't it? Because fun, we knew, would be 3 factorial. If we did 3 factorial over here, we would claim to have 6 possibilities here. But, right, so if we did what we had done before, that would give us 6 possibilities. And here's the problem. We could start with M, and then we should have a choice of O sub 1, say, or O sub 2, versus O sub 2 or O sub 1. We could put M in the center. We could put M at the end. But however we switch up those O's, they look the same. They're identical. And so what I really want to do is, I notice that I can get rid of that, I can get rid of that, I can get rid of that. So I really have 3 choices. And what I'm going to do is I'm going to take the number of possibilities if they were distinct, and I'm going to divide by 2 factorial, because I have 2 O's that are repeated. So in any situation, there are 2 factorial ways for me to reproduce those 2 O's. Oh, and here we have a puppy again. Well, 5-letter code words. I would like to say it's 5 factorial, but I have 3 P's. So I'm going to divide by 3 factorial, because there are 3 factorial ways I can arrange P sub 1 and P sub 2 and P sub 3. The other way we can think of this is that if you have 5 slots to fill, really, you could approach this by saying, where am I going to put the U and the Y? And that really is all you need to worry about, because everything else gets filled with the P. So you might say, in those 5 choices, right, where am I going to place those 2? So it could be 5, choose 2, which in fact is still going to give us 5 factorial over 3 factorial. And the next question, same situation. We have the word asymptote, which has, oh, how many letters does it have? 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. So I would like to say that this is 9 factorial, except that I have 2 T's. So I need to divide by 2 factorial, the number of ways I can arrange those T's. And the same thing with parallelogram. Parallelogram happens to have 13 letters, I believe. So that's 13 factorial. But then notice how many A's I have. I have 3 A's, so I need to divide that by 3 factorial to get rid of those reproductions. I have 3 L's, so I need to get rid of those reproductions. And let's see, what else do I have? I have 2 R's, so I need to divide by 2 factorial. And finally, for question 10, we have 2 events here. We need to pick 2 women and 2 men, and certainly order matters. Being assigned a chairwoman is different than an assistant chairwoman. So the first event is to pick from the 21 women 2. And then second event is to pair that with, from the 14 men, we're going to find all ways of ordering 2. So this is the number of ways that we can choose what we need to choose for this.